Okay, for this one, I put an instructor tip in there. It does ask for something that we don't do a whole lot of, so I just wanted to let you know. I don't want you. Sometimes in the question help, they do things by hand, and I almost always will do it using StatCrunch or the calculator. So for the Spearman row statistic, I must ask for that in one of the parts. Use StatCrunch, and then I tell you what to do. Go to Stat, Non-Parametric, and Spearman's correlation, and then select both variables and compute, and it'll give you that value. And you can always go back to that instructor tip. I think, yeah, there you go. Instructor tip, and there it is. Okay. So analyze the association between this. We have fast food is often considered unhealthy because much of it is high in both fat and sodium. But are the two related? Here are the fat and sodium contents of several brands of burgers. Complete parts A and B. Okay, so we got fat and sodium. So I'm going to open this up in StatCrunch. And I'm glad this put this in vertically. If you've got horizontal, it would not go well. You would need to transform that. You could have to go into data and arrange and transpose those two columns. Sometimes I've got to do that. Okay, so let's go ahead, and we got sodium on the y-axis. So I just want to make sure I pick the right ones. And I'm pretty sure I'm going to be creating a correlation with this, so let's go ahead and just go to that. So stat, regression, simple linear. My x is fat, y is sodium, and that could have easily been switched. I'm just kind of looking at what they did. Sometimes one of them is a clear indicator, like number of hours studying versus test score. But this one, it's not really clear which one is causing the other one, if there is any causal thing to put here. Fitted line. And let's press compute. And right now, this first one, I'm just looking at the graph. Ooh. So that's an interesting graph, right? So here's my scatter plot, kind of all over the place, isn't it? So I've got these three values here, which are pretty low, and then these values here. Notice my line here. Very small slope. You can barely tell it's sloping at all. It's a slope of 0.08, 0.077. And this line obviously does not really match any of this data. So very interesting data set indeed. So which one does that match up with? Okay, so this one was actually a little tough for me to... It's between C and D, right? So I had to actually blow this up a little bit. And we can tell that, let me blow both these up. So if that's 1700, and then 1600, 1500, 1400 is that one. 1615 is that one. So which one of these is at 15? That's mine right there, at about 1505 in this case. So it's the one that's at 1505, so this one here. Kind of a cheap shot in my case in this particular example, I think. If you put the wrong one, you get a couple choices on this one. So D. So what is the correlation coefficient? Let's go back. Is 0.00025. I didn't catch the rounding to 3 decimals. So 0.002. 0.00246, so 0.002. Okay, which of the following best describes the association between fat content and sodium? So strong positive linear, no. Moderate positive linear, no. Strong curved, no. Strong negative, moderate, no apparent association. Find Spearman's row for these data. So let me go in here and I'm going to select stat, non-parametric, and Spearman correlation. It says select both variables and compute. And there we go, negative 0.126 I really should check rounding first. 3 decimals, 0.126. Okay, so then we get Spearman row. We use that when it's sort of distribution free. When we have sort of wonky things that look like that, we have to turn to non-parametric statistics. We're not going to do a whole lot of that in here, but it does come up sometimes. So Spearman row is definitely less than the Pearson correlation. And it minimizes the outline, the influence of outline points, because it basically ranks them. And the general assessment association from Spearman row is the same, is that they're both very, very low. So I hope that helps.